Hi, my name is Yuri Kolomiets, and I'm a Solutions Architect at Corsa Technology. I would like to show you a technical demonstration of BGP Flow Spec support on Corsa NSE 7000. NSE 7000 is a transparent, inline, Layer 3, Layer 4 network security device that controls traffic via user-defined programmable rules. These rules can be programmed using REST API or BGP Flow Spec. And in this particular demo, I will show you how NSE 7000 fully supports BGP Flow Spec. In your security architecture, you have a centralized system that aggregates all your security intelligence. We call it the brain. The security brain aggregates all the sensory inputs from all other security systems, such as network anomaly detection, security events, user and endpoint behavior, threat intelligence, and many others. Once the brain has determined that there is an attack or some other security incident, it needs the ability to respond to it within the network. This is where NSE 7000 comes in. We like to call it the muscle. It is the fastest security device on the market that will never compromise your network uptime or performance. And it gives your security brain the ability to react within the network in real time. NSE fully supports BGP Flow Spec standard, and you can configure hundreds of thousands of rules to match on every possible header field as defined by the RFC. NSE supports the following actions on every single rule: accept, discard, rate limit, remark DSCP, and redirect to another inline inspection device. In this demo, we have three different scenarios of how you may want to use the NSE, and I will show you how you can do it using BGP Flow Spec. In the first scenario, we have a confirmed high packet rate DDoS attack. And what we'd like to do is block UDP packets on port 19 that are smaller than 128 bytes. Now, what we're going to do is we're going to install a filter that blocks destination 10.10.10.10, which is the victim. Protocol UDP port 19 packet length is less than 128 bytes. And the action is going to be discard. What I have here is a Spirent traffic generator. And I have 4 different traffic streams that correspond to my 3 different scenarios. The first traffic stream corresponds to my first scenario that I just described. What you see is actually the effective rate, because the packet rate is so high and the packet size is so small, the effective layer 2 rate is actually not even full 25% of what I'm sending. What I have here is a system, my client system, that's running ExaBGP. It's an open source BGP speaker. And what I also have here is an NSE 7000. So what I'm going to do is I'm going to show you a couple of scripts, the 3 scripts that I have corresponding to each scenario. So here I have announce UDP packet length. So it'll just feed this line to the BGP speaker, and it will announce this rule to the NSE. So if I pass this into the process, you will see here immediately the traffic on that one stream that corresponds to UDP port 19 packet length less than 128 goes straight to 0 right here. And if I look on the NSE, I will see that I have a 1 rule installed, and this is the rule that we just installed using BGP Flow Spec. So for my second scenario, I have a suspicious high rate of UDP fragments. So from my network anomaly detection, I determined that there's very high rate of UDP fragments. And what I would like to do is rate limit all the fragments that are coming from this source to this destination to 1 gigabit. So maybe I don't want to kill them all and drop them all. And the 2 streams that correspond to this scenario are stream number 2, so for the first frag, and stream number 3 for the middle frag. And here I have another script. It's very simple. All it does is announces this rule based on source, destination, protocol, and fragmentation bits. And what we'll do is rate limited to 1 gigabit, which is 125 megabytes per second. And as soon as I announce it, I will see that on my Spirent, immediately the traffic will drop, but not all the way to 0, since we left it about 1 gigabit. And if you see, these two streams add up to about 1 gigabit per second. And if I look on the statistics on my NSE, you will see two rules now. So I'm pulling this using CLI, but you can just as easily pull it using REST API and integrate it into any of the monitoring tools. And you will see this rule effectively taking together about 50 gigabits per second, which is 60 gigabytes per second. And then for the last scenario, I have a high rate of connection resets on a host. So what I would like to do is just monitor the number of TCP reset packets that this IPv6 host is receiving. So we're not going to drop anything. We're just going to introduce a rule that will permit everything and count how many reset packets this IPv6 host is receiving. So if I go back to my BGP speaker, I will see more IPv6. So this is the rule corresponding to this scenario. It's an IPv6 host with TCP protocol and TCP flag equal to reset. And as soon as I announce it, you will notice that the rate doesn't change. So my traffic corresponding to IPv6 TCP resets still continues unaffected. But on the NSE, I will see three rules now, this one corresponding to IPv6, and I get a counter for packets, bytes, packets per second, and bytes per second in real time of what is going through the NSE. So these are the three different scenarios that I wanted to show you, and they demonstrate how NSE 7000 fully supports BGP Flow Spec, and also they give you some idea of how you could use it as a control point within your network. For more information, please see our other videos or visit Corsa.com. Thank you very much.